So I am Prateek Tripathi from Indian Institute of Technology, Roorkee, India, and this is my second curation grant, and first was in 2021. So today I am going to present two best comparison which I did in last 6 months. So first I will give an overview. Can you change this slide? Second slide, please. Yeah. Okay. So coming to my PhD thesis topic, I basically work on the integration of different remote sensing and non-imaging remote sensing techniques for mineral classification. But as I said during my first ORKG grant, I worked on the planetary science aspects, and really it helped me a lot during my PhD. So now, in my second curation grant, I basically focused on the earth sciences part. So here I moved to I kept the remote sensing thing as it is, but I moved to the vegetation and agriculture application, which is very crucial for Indian subcontinent. Can you please change the slide? Coming to this grant, these are the few research topics covered, which in my previous grant, I worked on as I told, I worked on the planetary sciences, so mostly the minerals were covered. But here, I got the chance to work on the crop and agriculture part. So I included agriculture, crop health, crop classification, agriculture management, crop monitoring, engineering, image process, including the image processing, signal processing things, techniques, which are very crucial in getting the end product for a remote sensing part, for the agriculture part. Also, most of these papers include statistics and machine learning. So basically, all these research fields covered have earth sciences and remote sensing in agriculture field. So can you please change the slide? So here comes the best comparison, the first best comparison which I prepared. So it uses different multispectral remote sensing data sets for crop classification all over the globe. So I chose 6 papers, and all are from Earth Sciences field. And as you the problem with the multispectral data sets in remote sensing that their end products are very fancy, but most of the new students, scholars, and some core scientists which are new to software developing team, and a lot of the policymakers, they don't know how to process the data. So in last 6 months, I focused on the Landsat 8 and Sentinel-2 datasets. These are the most commonly used datasets in the remote sensing field for the agriculture. So I focused on these two datasets, and I compiled all the pre-processing and techniques which were used, majorly used for these data set to get the final products in agriculture and vegetation. For example, crop map in a very big area. For example, how much wheat crop is disease free and other things, like what is the land cover and land use percentage in area, how much land is occupied by the wheat crop and how much by the bajra crop, something like that. So and this gave to the this is kind of a solution to the research problem, that how the two crucial most used multispectral remote sensing data sets can help to solve the current issues in agriculture application. So using both two data sets, I enlist few review and research paper on remote sensing application in agriculture for crop classification. This comparison will be I believe that this comparison will be very helpful for the all general users of ORKG to get a broad idea about the latest advancements in remote sensing technology for crop management. So I will just share a few screenshots. I just put these screenshot because I can't share my screen. So can you move to the next slide? There are animations, so I will just ask you to change the animation. So in the next slide, you can see that these are the few papers, and uh, uh, so yeah, just a sec. So you can see that these all papers have different research problem, and all these research problem focuses on the crop identification or the distribution or the classification. So the best thing about the ORKG is that it if a student is working on classification and identification, he or she has to search different papers. But best thing is the ORK is that I compiled all these different application and vegetation papers at a single page. So in the first paper, you can see these are the different application of paper covers. For example, crop spatial distribution, crop type monitoring, decision making. So the thing is that the major thing is there that ORKG gives you freedom to compile a lot of papers covering different vegetation and agriculture application in a single place. So also you can see some land cover classification, crop disease detection. Also, like it's kind of a very diverse agriculture field papers compiled at a one place. Also, coming to the study area, you can see the study areas are spreaded all over the globe. So I deliberately chose them to get an idea how the researchers are using remote sensing data and multispectral remote sensing data sets for the agriculture application. Next animation, please. Okay, so here you can see that like you can see that people mostly used a GPS handheld device uh, in all the field work because it is very necessary to verify your remote sensing data set with the field data set. So ORKG gives you freedom to include these GPS, and I am planning to include more papers like this where with the accuracy of all these GPS systems. For now, I haven't included the accuracy of these systems. Also, the main part is sensors. So here you can see most of them use Landsat 8 and few Landsat 5 and MODIS and moderate resolution imaging spectrometer. So basically Landsat 5, 7, 8, 9, this is a series by US, and it's a very wonderful series which gives you a lot of freedom to remote sensing person. It's called the lifeline of remote sensing person to rely on these data sets and give some good results to policymakers. Uh, Next animation, please. So here you can see different pre-processing techniques. So this is very, very crucial because most of the new students and the scholars don't know about these pre-processing. And if you're not knowing any of these pre-processing steps, then you can't get very good results or the accurate results. So you can see that I have written atmospheric correction in every column. So when you see their definition, most of them are same, but there are a lot of atmospheric correction models used in the remote sensing datasets all over the India due to the different and random weather condition all over the globe also. So that's why I have iterated them to each column. Also, image to image registration and radiometric correction. These are the basic steps which mostly students forgot actually. So coming to the techniques, there are, you can see a lot of statistical techniques are used in the remote sensing thing. So this is the best thing that ORKG can do with a student, so that if a student coming from the hardcore statistical background or a technical background, they don't have to worry about learning new remote sensing techniques, because these techniques are nothing. Just they are the statistical technique working on the image, and image is nothing, just a matrix of digital numbers. So, and can you move to the next animation? So coming to the outcomes, you can see the initially when I chose the agriculture, so I was like, I have to I was thinking to give just a keyword in the outcomes, but when I saw the results of these papers, they were like very big sentences, and you can't just summarize them in one or two words without thinking of the their impact on the students or the other policy makers. So. I have included medium-sized sentences because if I didn't do that, then there's no meaning of making these comparison here. So you can see, like if a student is looking at this comparison, and if he knows that okay, Landsat data used for a particular age with this technique, so he or she must know how much is the accuracy with the different application method. So you can see like for accuracy using SVM and ML in the first column, and in the fourth column for Illinois and Iowa, their different accuracy and kappa coefficient. So ORKG gives you the freedom to write all of these without any word limit. And in the bottom, you can see the data resources. Can you move with the next slide, please? So here is the generalized review of remote sensing sensors and methods to the various applications. So I followed this in my first grant also in this and using it right now so in this second grant because it is a demand of those remote sensing papers which I wanted to show in the ORKG because they follow a similar type of pattern. They not always give you the numerical values or output, they give you inferences also. So I selected some research problem and discovered some research paper on that and just narrowed down the research problem sentences in 5 to 6 words and search for the sensors which had been used. So I didn't skip a single sensor even the author used it for the verification. I included every census because I don't want to give an impression to the original author of the paper when they look at ORKG. Oh, he didn't included that sensor. I used that sensor. So I tried to be very accurate with all the sensors used, although they are very repetitive. But I think this is the best thing we can do to give a very to give ORKG more reliability for the other users. So coming and then after that, I selected the analysis, search for the analysis in the papers and techniques and methods. So techniques and methods are mostly same if we are going for crop identification and crop classification, but their outputs are different. Also, the pre-processing and field work is very, very important, which is the goal for a student. And coming to the then I listed the outcomes. So I mostly prefer the CSV format for the comparison for importing the comparisons. So this is the second comparison, which I think is also important. So it focuses on the use of satellite data set for crop disease detection, which is very, very important in Indian subcontinent especially. So the advantage of having uh, these sorry, I didn't say the move to the next slide, but I hope you are seeing the comparison too. I'm sorry for that. So these techniques can aid in timely intervention and targeted disease management, and ultimately contribute to improved crop health and yield. So in this comparison, I tried to show the use of different satellite data sets, not only the multispectral satellite data set that can use for the timely detection in crop or disease in crops for better irrigation and management. So timely, I'm focusing on timely things because it is very, very important to know about these disease on time. For example, if in a brinjal field, if any of the disease and any of the crops are diseased, then there is a high chance if we didn't get the timely scan done, it will spread to all over the field. Next slide, please. So here you can see again an animated slide in which the different research problems are listed for all the papers, and here you can see that crop disease detection is a very big word. So you can ORKG gives you freedom to give more than one name to the application. For example, in the first column, crop condition assessment, crop disease detection, crop growth management, disease infestation detection. So these are all come under crop disease detection. Similarly, for other application in the research papers. So I tried to explain all of them, but few of them are self-explanatory. For example, monitoring and detection of plant phenological changes in the fourth column, and and early detection of disease in the fifth column. Can you move to the next animation? Yeah. So here you can see the study area also spread all over the world. So this image is not showing last two columns, which have Indian study area, and if you see the sensors used here. So here Lancet and another high metal cupid, they are the spaceborne data set. However, the digital multispectral cameras are airborne data sets on a drone. Similarly, in the fourth column, you can see a field-based data set. So field-based spectrometer. So this comparison is a combination of spaceborne, airborne, and field-based sensor. So it is the results here are very diverse and very important. Can give a very important conclusion regarding the disease detection. So they all use the GPS data sets and other. You can see the differential GPS in the second column also. So these are the field. These are the field work instrument used in these in these papers. Next animation, please. So here you can see the pre-processing techniques. These are the almost same, but you can see in the last column that logical operations were also used as uh, uh, in the pre-processing for remote sensing data. And coming to the techniques, you can see they had used NDVI. So I have prepared a lot of comparison based on based on indices. So NDVI is normalized difference vegetation index. So it basically gives you the vegetated area in a particular image. So it's a very simple index, but these indices are very, very important for agricultural applications of remote sensing. And you can see a name bias freedom test in the fourth column and KNN in the fifth column. So these are all the statistical techniques which were used in these papers. Next animation, please. So now coming to the outcomes, you can see most of these are the inferences. So that was I was talking about. Said they didn't give very like they did each paper didn't outputs accuracy or some numerical value. So they gave what they found, what they did with the NDVI value. So for example, assessment of infested area, control of infested seed, management of infested soil, and you can see some of them gives the balanced accuracy in the index in the fourth column. So these are the some outcomes like inference weight outcome and some used some approach which I think was not good to define here. As you can see in the fifth column, RFE cluster approach. So I explained it as a resource, and if you want to know, you can just go and click there. So next slide. So these are the two comparisons which I wanted to show. Also, I would like to thanks to ORKG to giving me the chance again. Although this time I was kind of little late in preparing the comparison because I was busy with my PhD defense in September. So I would like to thanks that. The ORKG because it helped me during the first creation grant. It helped me a lot in my PhD literature review and thesis preparation. And during this second grant, I got a lot of help because I prepared some proposal and submitted for my postdoc, and I got some very good feedback from the recruiting societies, and they really appreciated my involvement in ORKG. And when they found the number of papers which I reviewed, they were very happy. So ORKG honestly played a very great role in my PhD and post PhD work. So thank you very much for listening to my talk.